CoreOS is an open-source lightweight operating system based on the Linux kernel and designed for providing infrastructure to clustered deployments, while focusing on automation, ease of applications deployment, security, reliability and scalability. As an operating system, CoreOS provides only the minimal functionality required for deploying applications inside software containers, together with built-in mechanisms for service discovery and configuration sharing. CoreOS is a fork of Chromium OS, by the means of using its software development kit freely available through Chromium OS as a base while adding new functionality and customizing it to support hardware used in servers. As of July 2014, CoreOS is actively developed, primarily by Alex Polvi, Brandon Philips and Michael Marineau, with its major features available as a stable release. Overview: CoreOS provides no package manager, requiring all applications to run inside their containers, using Docker and its underlying Linux containers operating system, a Euro-level virtualization technology for running multiple isolated Linux systems on a single control host. That way, resource partitioning is performed through multiple isolated user space instances, instead of using a hypervisor and providing full-fledged virtual machines. This approach relies on the Linux kernel's groups functionality, which provides namespace isolation and abilities to limit, account and isolate resource usage of process groups. CoreOS uses systemd as its primary init system, with tight integration between it and various CoreOS internal parts. Updates distribution: for additional security and reliability of updates, CoreOS employs fastpatch as a dual partition scheme for its read-only root file system, meaning that the operating system updates are performed as a whole and installed onto a passive secondary root partition, which becomes active upon reboot or kick. That way, easy rollbacks to known to be stable version of the operating system are also ensured, and each boot partition can be signed for additional security. Writable parts of the file system are stored in a separate state partition, which is automatically resized to fill all available disk space upon reboots. CoreOS updates distribution system is based on Google's open-source Omaha project, which provides a mechanism for rolling out updates and the underlying request a Euro response protocol based on XML. Additionally, CoreOS provides Core Update as a web-based dashboard for the management of cluster-wide updates. Operations available through Core Update include assigning cluster members to different groups that share customized update policies, reviewing cluster-wide breakdowns of CoreOS versions, stopping and restarting updates, and reviewing recorded update logs. Core Update also provides a HTTP-based API that allows its integration into third-party utilities or deployment systems. Cluster infrastructure: CoreOS provides etcd, a daemon which runs across all computers in a cluster, allowing configuration data to be easily shared by providing a dynamic configuration registry. Since the key Euro value data stored within etcd is automatically distributed and replicated, all changes are reflected across the entire cluster. Beside configuration management, etcd also provides service discovery by allowing deployed applications to announce themselves. Communication with etcd is performed through a simple API, which internally uses JSON on top of HTTP. The API can be used directly, or indirectly through etcdctl, which is a command line utility also supplied by CoreOS. CoreOS also provides Fleet, a cluster manager daemon that controls CoreOS separate systemd instances at the cluster level. By using Fleet, CoreOS creates a distributed init system that ties together separate systemd instances and a cluster-wide etcd deployment. Internally, Fleet daemon communicates with systemd over dbus. Using Fleet allows single or multiple containers to be deployed cluster-wide, with more advanced options including redundancy, failover, deployment to specific cluster members, dependencies between containers, and group deployment of containers. Command line utility called fleetctl is used to configure and monitor this distributed init system. Internally, it communicates with the etcd cluster. When used locally on a cluster member, fleetctl communicates with the local etcd instance over the loopback interface. When used from an external host, SSH tunneling is used with authentication provided through public SSH keys. Both etcd and Fleet are written in the Go language and distributed under the Apache License 2.0. Deployment: in addition to running on dedicated hardware, where it can be either permanently installed to disk or remotely booted via PXE or IPXE, CoreOS supports deployments on various hardware virtualization platforms, including Amazon EC2, DigitalOcean, Google Compute Engine, Microsoft Azure, OpenStack, QEMU KVM, Vagrant and BMW ARE. See also. References. External links.